So today we'll be able to identify the population as sample in a statistical study. We will identify voluntary response sample and convenient samples and explain how these sampling methods can lead to bias, which of course is bad. And then describe how to obtain a random sample using slips of paper technology or a table of random digits. All right. A population is simply a group we want information about. It could be the electorate in the United States. We could be doing a presidential poll. Okay? It could be the toasters. We want to know which toaster is the best, which toaster is the worst. Okay? It would be the population of toasters. The census collects information from all members of the population, which you can understand how that might be tough. And the United States does it once every 10 years because it's that tough. Or we try to get information from all the individuals once every 10 years. We try to perform a census. It's unlikely that we actually are getting information from all members of the population. We call it a census, and it is, but because our goal is to collect information from all members of the population, but we rarely reach that goal. Okay, a sample is it's a subset of a population from which we gather data. Okay, so when we do a presidential poll, we don't ask all 320 million Americans who they're voting for. We ask, about 1,500 is usually about what the sample size is. And then we infer things to be true about the entire population based on what the information we get from the sample. That's inference for. Okay. One more term we should know is a survey, which is just an attempt to gather info from a sample. Okay. So let's look at this example here. Students and soda. We're going to identify the population and sample in each of the following settings. The student government at a high school surveys 100 students at the school to get their opinions about a change to the bell schedule. Okay, so if we look at the sample, it says they survey 100 students. That's the sample. Now the population has to include everybody in the sample and everybody that's similar to them. And so that in this case, since they're surveying 100 students, the population is all the students at that high school. Okay. B, the quality control manager at a bottling company selects a sample of 10 cans from the production line each hour. Let's underline that, 10 cans from the production line every hour to see whether the volume of soda is within acceptable limits. So this would be the sample. Is that it says sample right there. Okay. The population is all cans for that hour, just for that hour, not all cans for the whole day, just for that 1 hour. Okay, so there's some examples of population and sample. All right, let's look at how do we sample badly. How do we sample badly? Well, there's a couple ways we can do it. Okay, and you've seen a lot of them, especially if you're taking online surveys or online, polls. You are being sampled badly with what's called a voluntary response sample. And there are more examples of this, but other than just online ones, but almost all online polls are this way. I would say all, because it probably is all, but you hate to be that sure of yourself. Okay, and it's a voluntary response sample if people choose themselves after a general invitation. Now, another example of this is if you heard of people on the radio asking questions and they have call-in. People call in and give their opinion. Okay, call-in, that's one. Okay. The problem with a voluntary response sample is usually it's people with strong opinions or that just like to hear themselves talk sometimes. The sample is usually not representative of the larger population. Okay. And another one is called a convenience sample. You know, and I call this a mall walker sample. It's a sample of people who are easy to reach. Okay, so that's why I call it a mall walker sample, because you'll have companies that they work out of the mall, and all they do is stop people in the mall and ask them questions and see if they can't survey to try to get information from them. And that's fine if you're only interested in people that walk the mall or people that spend a lot of time at the mall. But if you're interested in the population in general, you have to have people that maybe don't spend as much time at the mall, or people that don't go to the mall at all. They have to have an equal chance of being chosen. So a convenience sample. Right? So bias. A survey can be biased, or the results can be biased if the design of a sample is biased if it would consistently underestimate or overestimate the value you are interested in. Okay. So let's look at this example. In May 2010, the Los Angeles City Council voted to ban most travel and contracts with the state of Arizona to protest Arizona's new immigration enforcement law. The Los Angeles Times conducted an online poll that asked whether the City Council was right to pass a boycott of Arizona. The results showed that 96% of the 41,068 people in the sample said no. What type of sample did the Times use in this poll? Explain how the sampling method could lead to bias in the poll results. Well, it was an online poll, so this was a voluntary response sample. Okay. And how could this method lead to bias in the result? Well, people with strong opinions against may be more likely to respond. To the poll. Okay. Skewing the results. So we talked about how to sample badly, but how do we sample well? Okay. How do we sample well? And by the way, in this last one, skewing the results, it's likely, obviously likely, that the 96% is a lot, much higher than the actual percent of LA residents that would respond no. Okay. All this shows is that 96% of the people who cared enough to get on and voluntarily respond said no, but it doesn't mean that all the people in LA would, 96% of them would say no. Okay, how to sample well. Okay, one biggie to begin with, and that is your sample has to be random. Random sampling. Okay. So we use a chance process, and we'll talk about those in a minute, to determine which members of a population are included in a sample. Okay. We have something called a simple random sample. Simple random sample, or SRS, which you'll see it referred to as SRS all the time, of size n, is chosen in such a way that all samples of size n have the same probability of being chosen. Okay, same probability of being chosen. Now notice it didn't say that every individual has the same chance of being chosen. Usually that's what it is. Every individual has the same chance of being chosen, but sometimes that's not enough, and we'll see that as we move forward. But there are three main methods, and the first one is the one I would recommend that you use on the AP test, the HAT method. Even though sometimes when we'll say we'll use it, it wouldn't be very practical to use, but, okay. And the HAT method can be done a couple ways, but one way is to put the names of all the individuals. Okay, you could also number all the individuals and choose numbers, put the numbers on these pieces of paper we're going to talk about, on equal sized pieces of paper. It's important that they're equal sized pieces of paper. Okay. Put all the pieces in a hat, mix well, and draw n names. However big your sample size will be, and of course will be your sample size. However big you figure that should be. That's the HAT method. And that's the one I would suggest that you use. Okay? Would definitely be that one. Okay? A second method would be the technology method. And given a choice, this is the one I would use if I would use this one if I couldn't use the HAT method. Okay. Label all the individuals. Okay. With a unique number 1 to n. N is again your sample size. Okay? Use randint or any random number generator, but this is the one on the TI-84. 1 to n, 1 comma n. So it starts at 1 and it goes to n. Okay? To select n unique integers between 1 and n. Or not n, actually, yeah, n from 1 to whatever, between 1 and whatever. Okay, I said back here that the 1 to n, but 1 to are not, let's call it 1 to x, which is the population size. So everybody in the population should get a label from 1 to x, and then we do 1 to x in our random number generator as well. Okay? All right. Now, give myself a little room here. The last method is called Table D. This is not, I would only use this one if absolutely had to, and probably only on the multiple choice or if they force me to use the table of random digits on the test. Otherwise, I'm probably not using this method. Okay? So we again label each member of the population with a numerical label with the same number of digits. So you might, instead of having 1, you'd have 0, 1 to 99 maybe. Okay, because 0, 1, 0, 2, 0, 3, they still have 2 digits. They all have to have same two digits. Okay? Go to a table of random digits. And read consecutive numbers spelled correctly here. Let me fix that. Consecutive numbers from left to right with the appropriate amount of digits. Ignore repeated numbers and numbers outside the range. Okay. And I'll do an example of this in the next video as we go here.